Okay, for these, what you're doing is you're going to sketch any two triangles that you want, okay? Make it easy on yourself. I'm going to just make them pretty close. Try to make them congruent. Doesn't have to be perfect. A, B, C, and then use, okay, so then it's A prime, B prime, C prime. You know, make it easy for yourself and put them like this. Now, here's what it's saying. You would mark the diagram based on the givens. Okay, so AB is the same as A prime, B prime. BC is the same as B prime, prime, C prime. And angle A is congruent to angle A prime. Now, is that enough to prove the triangles are congruent? The answer is no. Okay, here's why. This is two sides and an angle. Remember what I said about write down your two sides and then decide, does the A go between or to the outside? Now, this would be the between. If you had a pair of angles marked here and here, that would be between, and we'd say it's side angle side. It's not that angle, so it's side side angle. Okay? Now, we know side side angle is not a valid triangle congruence theorem. So it is not enough information to prove triangle ABC is congruent to triangle A prime, B prime, C prime. You just need something else. It's not enough information. Okay? So close, but not quite enough. All right, number 7, C is the midpoint of BE. You got to be careful. The only thing we can prove is that these are the same. Now, is C probably the midpoint of AD? Maybe, probably, but it probably is not good enough. We can't mark the other two sides. We can mark these because it's the midpoint of BE, so it cuts that in half. Now, BAD is congruent to angle EDA, right? That's given. And what method would we use, okay, to prove this triangle is congruent to EDC, this triangle? I would add something of my own, and that would be vertical angles. Okay. Now, which of the triangle congruence methods? It looks to me like, again, you got two pairs of angles, so two A's. Does the S that we have fit in between or to the outside? Well, this would be the in-between side. That's not the one. So it is it's going to be the angle-angle side triangle congruence theorem. Okay. Explain. Okay, that means we need some sentences as to why. Okay. Let's see. Angle BAD is congruent to angle DEDA is given. That is an A. Angle ACB is congruent to angle DCE by vertical angles theorem. I'll say are congruent, right? That is another A, which is a pair of angles. And BC is congruent to EC from that midpoint concept, which gives us an S. Okay, so that's my explanation. It's not a proof. I just tried to explain what went on. I'm sure that's plenty for an explanation. All right, how would we prove two triangles congruent by side, side, side? Simple. We show the lengths of all pairs of corresponding sides are congruent or equal. And, okay, equal length on the graph gives us sides that are congruent. So you'll need to calculate 6 distances and then show 3 pairs of those being equal. All right, what about hypotenuse leg? Well, first we have to show there is a right angle and on a graph that comes from perpendicular segments that means slopes will be negative reciprocals. Okay, that's your, right angle. Then the pair of sides opposite the right angle will need to have equal distances. Which gives us the hypotenuse requirement. And then third, then any other pair of corresponding sides will need to have equal distances for the leg requirement. So that's how we would do hypotenuse leg. So you have to calculate basically 2 slopes and 4 distances. That'll take care of it for you. All right, name the sequence of rigid motion transformations that would map triangle ABC onto. Okay. Now, there's always difficulty with these. You got to be really careful to not assume just because it looks like it would map in one move. You can't assume that. So our process is consistent. We need to match first. Orientation is how I show my students. So match orientation. If orientation is off, what we do is we line reflect. Now, we can be strategic about that line reflection or just any random side, that'll work. After that, we have to match a pair of points somehow that are supposed to be matched, okay? So in this case, you have to map A to D, okay? Now, the third move is going to be without losing the first match, get another one. That's going to be match a second without losing a second pair, okay, of corresponding points without losing the first. The way we do it in my class is then we rotate centered around whatever that first pair of match points was by an angle that's going to map another pair. Once you've accomplished these 3 goals, that's it. So here's what we'll do. We'll check orientation. Okay, triangle ABC. You're moving in a clockwise direction for ABC. DEF is also moving in a clockwise. So we don't need a line reflection. Orientation's matched. So kind of note that. All right, orientation right now is the same. So no line reflection. needed anyway. I mean, you could do 2, but that's kind of silly if we've already got the fact that it doesn't need one. So what I'll do next is I will translate triangle ABC to map. Now watch, it's going to be angle A, or sorry, point A to B. A onto D. Okay? Now what's going to happen is every point is going to move by that same amount. I'm going to assume it's going to look a little bit like this, right? Here's B prime, here's A prime, and here's C prime. Okay, so it's not quite there yet. Now, from there, what we're going to do is we're going to rotate triangle A prime, B prime, C prime. Centered, this is the key to this, centered at D. We don't want to lose A. We've already mapped that. We don't want to lose it, so we're going to center our rotation at D, so it's going to become an invariant point. So centered at D by an angle that simply maps B prime onto, now I just picked any random point that I didn't know if it was matched. Now B prime has to map to, think about it, E. Okay, and that's it. Once we have 2 points and orientation the same, it's over. We know for sure that we've accomplished our goal. Okay, so that's how we're going to do it. Translate, rotate when you don't have to line reflect. All right, for B, let's see how we're doing on time. That's enough for this video. I'll do another one on the next one.